Hello students, welcome to the session of data mining. In this video, we are going to learn about the density-based clustering algorithms. So in the previous video, we have learned about k-means, k-median and all, right? So all those algorithms depend on the centroid or the mean of the data points. So due to that, whatever the data points which we take, it will be clustered into one or the other cluster. So we cannot find the outliers easily using those methods. But density-based clustering methods, they are dependent totally on the density. It means that what are the points which are connected within the dense area. Okay, and here it will help us in order to cluster the arbitrary shaped data points. So here we can see the clusters not only in the spherical shape, but also the arbitrary shaped clusters also can be found using this DBSCAN. And it also identifies the outliers. And we can do this task in one scan. And here we need the density parameters as a termination condition. So let's understand what the different algorithms we have in this density-based clustering. Those are DBSCAN, optics, and DENCLO. So let us understand all these algorithms in detail. Coming to the DBSCAN algorithm, this DBSCAN, it is called as density-based spatial clustering of applications with noise. So here we'll cluster the given data points in the application, and also we can identify the noise or outliers which are there in the data points. So here it is a clustering algorithm which will group the data points based on their density and also uses its neighborhood. The data points, the neighbor data points are also used to make the clusters of those data points. Now here it uses majorly two parameters, which is called epsilon and the other is called the minimum points. What actually is this epsilon is, it defines about the neighborhood of the data point. It means that, so basically let us consider this is a point, right? And here the neighborhood of this data point can be known by this epsilon. This represents a radius which will form the cluster. So this is used to find the neighborhood around those data points. So if the distance between any 2 points, if it is equal or less than or equal to this epsilon, then we consider that as the neighbors. And here we will choose the value of the epsilon. If we choose this epsilon value as very small, so a larger part of the data which are available, the other data points which are available in this in the data set, it may be considered as the outliers. If you are choosing this epsilon value very large, all the data points which are there, all will be merged into a single cluster. So we should be very careful while identifying or taking the epsilon value. And the other parameter we'll consider is the minimum points. So in the minimum points, this how many number of neighbors can be present within this epsilon radius, that we consider it as a minimum point. Suppose that if you are taking minimum points as 3, so at least there should be some 3 data points among this radius or the whatever this cluster which are formed, which is using this epsilon radius. Now if your data set is larger, then we'll consider the larger value of minimum points. And if you're having any n number of dimensions in your data set, suppose you are having 4 dimensions in the data set, the minimum points should be greater than or equal to the 5 value. So it should be more than 5. The minimum points around this epsilon should be at least 5. Now basically or generally we'll take this minimum point value at least as 3. So we have understood about this epsilon as well as minimum points. Now let's understand about the density. So here Along with that, we need to know about the three different data points, which are called core data points, border data points, and noise data points. So what is this core data point is? It should have at least minimum points within the distance of epsilon. So here, look at this example. Here we have epsilon as what? 1 unit. So let us consider this is a point and it has having an epsilon, and using this epsilon, there is a cluster, right? So within this epsilon, there should, here the minimum points are how many? 4 points. So within this epsilon, we need to have at least 4 points. So we can see that within the same radius of epsilon. So we can see there are many more than 4 points. So we can consider this as a core data point. If this core data point, if it is having the minimum points which is given, it should have greater than or equal to the minimum points which is having, then we call it as the core data point. So what is the border data point? Is a data point which is within the epsilon distance from the core data point, but it's not a core point. So here you can see, here we are, let us consider that this epsilon is having the 1 unit of radius. So similarly, from this core data point, this point is having the 1 unit of radius. So when you just consider this and draw a shape or circle, then what happens? The other data points, the count of the data points is less here. So we are having only 2, but actually the minimum point should be 4. So it means that it is not a core point, but it is considered as the border point because it is within the epsilon distance from the core point. So this is our core point and it is within the epsilon distance of this core point, that is it's called border point. So this border point, it is not considered as a core point. Now what is noise data point is, it will not be either under core point, it will not be either under border point. So whenever we get this noise data point, we generally call it as the outlier. Now, along with this, let's understand what is density reachable and what is density connected. So to understand this density reachable, first let us know what is directly density reachable from I1. So here, let us consider there are 2 points, P and Q. So let this P be the core point. It means that within the epsilon, it is having the minimum points, right? So this P will be directly reachable from Q if this Q is within the epsilon radius of this P. And then what is density reachable is, here we have 2 points like I and J, right? So we'll consider the minimum points as well as epsilon, and we'll have the sequence of chain of points which will reach from this I to J. So this sequence of chain will be created using the epsilon as well as minimum points. So for example, here we'll consider it as I1, I2, I3 and all. So till it reaches to IN, we'll have I1 to IN points, right? So in this way, it will create the chain of reachability. So here we say I1 to I2. This is called directly density reachable. And this I2 point is directly density reachable to I3. So in this way, it will form a density reachable from I to J. Now, what is density connected is, here a point, we are having I and J, right? So using the epsilon and minimum points, if there is an extra point called O, which will, so using this O, we'll be considering this I and J as the density reachable from O with respect to the epsilon and minimum points. So instead of residing an I and J, we'll have an extra point O, such that this will be density reachable from I or J. Both will be density reachable from this O, right? So using this, we try to find out the points which are very closer in terms of density. Now, let's see about the DBSCAN algorithm. So, density-based algorithm. So let us consider there is an data set with some x1 to xn points. So here, as we already discussed, the DBSCAN, it requires two parameters, which is called epsilon as well as the minimum number of points. First, we need to identify the value of epsilon and minimum number of points that are to be considered. Next, we'll be starting with any of the node, and then we'll identify the neighborhoods of those nodes, so which are present within the epsilon. Then if you get any other sufficient neighborhood around this point, then clustering process will start, and whatever the points which are marked as visited, so we'll once we find out those clustering, we'll mark that point as, once we have made the clustering, we'll mark that as the clustered. If that point is not clustered, we'll take it as the noise. And then if we find that point is around the neighborhood, we try to again perform the neighborhood, find out the neighborhood of this point, and then find out whether there is a possibility to form the cluster or not. So we'll be repeating this process until all the points in the data set are clustered. So, and we further visit all the unvisited points, and will form a cluster, or we try to identify whether it can be formed, whether it can form a cluster or whether it can form a noise. So this process will be continued until all the points in the data set are visited. Now, let's understand this with an numerical example. So here is an data set which consists of various data points from A to H, and also an epsilon value of 2.5 is given, and the minimum points here it is given as 3. Now let's understand how DBSCAN algorithm is used for this data set in order to create the clusters. Now, initially, we need to identify the neighbors of each data point, and to do that, we have to calculate the distance between the data point from various other data points which are available. So we need to calculate the distance from A to B, A to C, A to D, A to E, A to F, A to G, A to H, and all. Similarly, we have to calculate the data from B to the other points, C to other points. In this way, we need to calculate the distance between all the data points which are available in the data set. Now, to find the distance here, we are using the Euclidean distance. Using that Euclidean distance, we'll be calculating the distance from A to the other point, similarly B to other points, and C to other points. So we have to continue this till it reaches to all the data points which are there in the data set. And from Euclidean distance, we can see we got the values as 1.41, 2.82, 2, and there are different values for each distance which between the 2 points, right? Now, given epsilon value is what? 2.5. So the distance between this is represented in the form of a table. So here A to B, we got the distance as 1.41. 4, and A to C it is 2.82, and A to D 4.24. So here we need to consider the neighboring points. To consider the neighboring points, we will consider the points which are less than or equal to this epsilon. So here we can see A to B, the distance is 1.41, which means it is less than or equal to this, less than this 2.5. So we'll be considering this A to B neighboring point. So in this way, from the whole data, whichever the point is less than or equal to this 2.5, we will consider those distance to identify the neighboring points or neighboring data points. So here, suppose if you take A, so the neighboring data point for A is what? B. Similarly, if you consider B, the neighboring data point for B will be A and C. So we will consider those neighboring points when the distance between these points is less than the given epsilon value. So to understand this, look at here, A will have the neighboring point B, B is having A and C, right? Because we are considering this A and C because the distance of A and C is less than or equal to 2.5. So here this 2.5 refers to the epsilon value. Now, if you take the D, if you take the data point D, you can see the neighboring points as A, B, C, E, F, G, H. Among those points, whichever the distance between the 2 points is less than the epsilon, we'll consider that. So D to C. So D to C, what is the value? 1.41. Similarly, D to E, 1.41, and D to F, it is 2. So in this way, whatever the points that are less than this 2.5, we will be considering those points to create the neighbors. And here, this neighbors of D will be C, E, F, G, H, because the distance of the C, E, F and G, H is less than or equal to 2.5 from that particular data point D. After calculating the neighbors of all the data points, here we can see A is having the neighborhood of A is having 1 data point, and B is having 2 data points, C is having 2 data points. So here, along with the data set, it is given that the minimum points is what? 3. So we need to have at least 3 minimum points in the data. So here we have what data points as when you take the ABC data points, we can see only 2 points in it as a neighborhood. So it means that A, B, C have the neighbors which are less than or equal to the given minimum point, that is 3. So we cannot consider that A, B, C as the core points. But they have the ACBD as the neighboring points. So this may be the border points. So we cannot consider them as the outliers. And when you look at the points like D, E, F, G, H, we have the neighboring points as 4, 3, 4 and all, which is greater than or equal to minimum points. So these points D, E, F, G, H are considered as the core data points. Now, using this core data points, we can create the clusters. When you take the core data point D, we can see the neighboring points are C, E, F, G, H, which will form a cluster. Similarly, with the other data points, this D, F, G, H will form one more cluster. So, in this way, using DBSCAN and also with the use of this epsilon neighborhood and minimum points, we can find the clusters using the DBSCAN. Now, let's see the advantages and disadvantages of this DBSCAN. So coming to the advantages, this algorithm will work well for the clusters which have the dense points, and they when this is separated with the low density regions. So here we need not to have the prior specification of how many number of clusters that is required, and this also helps us in identifying the outliers. This DBSCAN algorithms, it is useful not only for the spherical size clusters, it can also perform for arbitrary sized or arbitrary shaped clusters. Coming to the disadvantages, so if you have any varying densities in the clusters, then DBSCAN algorithm may not work well. For that, we'll be using the optics. So let's see about the optics density based algorithm in the next video. Thank you.